Video tutorials. In this video, I'm going to give you complete overview and with examples on what is exactly Spark Core. Most of the beginners, when it comes to big data, Spark, most of the people will have a multiple questions. What is exactly cluster? What's the difference between Map Reduce and Spark? Why Spark? And what is exactly Spark Core? Okay, so today's session you will get a more clarity on what is exactly Spark Core and what is master and slave architecture, differences between Hadoop MapReduce and Spark. So before going to start big data, uh, you should have some basic idea on what is compute, what is cluster, what is the scaling, like a horizontal scaling and vertical scaling. Because when it comes to cloud projects, right, you should have some basic idea on what is vertical scaling, horizontal scaling. When you talk about on-premises, okay, consider if you have a 16 GB RAM, okay, which if you want to increase to more, so which you can increase. So similarly, on-premises, when it comes to every organization, they'll have a clusters or you can say servers on their premises. So that we will call it as a servers or you can say clusters, compute, basically compute. So which they can increase, that in a same mission they can go with a 16 GB. Just I'm giving a simple example to understand. 16 GB to 32 GB, 32 GB to 64 GB. So within a system, if you are increasing, right, so that is called vertical scaling. Like if you have a laptop or a desktop, consider initially you bought a 4 GB RAM, then increase to 8 GB RAM, then increase to 16 GB RAM. So if you are increasing within a system, that is called vertical scaling. And horizontal scaling is a major concept in cloud, and it will help you a lot. Most of the cloud data warehouses, MPP data warehouses, big data Spark, primarily focusing on this concept, horizontal scaling. So here, everything is a VM concept, virtual machine. If you're looking for 16 GB RAM, they'll assign one VM. If you're looking for 32 GB RAM, they'll assign another VM with the same configuration. So now you will get a 32 GB RAM. If you are looking for more capacity, then they'll assign another VM with the same capacity, third VM. If you're looking for some more capacity, then they'll assign another VM. So which you will get a 64 GB RAM. So these kind of scaling, we will call it as horizontal scaling. So based on demand, consider cloud is pay as you go. Pay as you go, like when you are booking Ola or Uber cab, right? Same thing. Consider if you want to travel 4 people, we'll book one cab. If you want to travel 8 people, we'll book 2 cabs. If you want to travel 12 people, 3 cabs. 16 people, another 4th cab. That is your ability to increase your compute capacity based on increasing demand of traffic. If you have a more demand, go and increase, then you have to pay for that. That is called pay as you go. Cloud basic concept is pay as you go, like Uber and Ola concept. Same thing. If you are looking for only less compute, pay for less compute. But when it comes to vertical scaling, which you need to increase on same mission, so which will have some limitations which you cannot go with more. Okay, like if you go before 2013, before 2011, right, that time if you're looking for a private cab, you need to reach one travel person, so they will be having 1 or 2 cars only. If you're looking for 10 cars for online booking, you cannot, that is not possible. That is called traditional. So now if you go for Ola or Uber, you can book n number of cabs. So they're having plenty of resources. That is called same thing like cloud. Cloud is having a plenty of resources which you can go and use and pay for that. That is called pay as you go. Okay, pay as you go. That's a basic concept. Like Uber and Ola, same concept, cloud also. This is about compute point of view. Then when it comes to CPUs, cores, threads. So most of the developers will have a common confusion in cloud because everything is a virtual machine, backend is a virtual machine, physically is a servers and cloud data center, right? So what exactly we will get in a compute point of view. So technically, if you talk about, consider you're having a laptop. So the laptop may be it's a single core. So one CPU, single core CPU, or dual core CPU. Two cores will be there, core 1, core 2, or quad core. So 4 core CPU. Then each core you will get a 2 threads. Consider if you go with a 4 core, core 1, core 2, core 3, core 4. Each core you will get a 2 threads. 2 threads means you can run 2 processes. You can run 2 processes. Technically, you can run 2 tasks. So cloud everything is a thread. We will call it as vCPU. Cloud everything is a vCPU, virtual CPU. It's not a physical CPU. Virtual CPU means one CPU you can run one task, nothing but you can process any one task. That we will call it as thread or process or task. So a physical CPU can have n number of cores. Physical CPU can have n number of cores. You see this is a dual core CPU. It is having a 2 cores. Then each core is having a 2 threads, so total 4 threads. So means 4 tasks you can run or 4 processes you can run. So nothing but 4 vCPUs. So this one, 2 vCPUs, single core, dual core, 4 vCPUs. Okay, 2 into 2, 4 vCPUs, quad core, 8 vCPUs. Like this you can go with that. Okay, each core can have a 2 threads, that's a 2 thread 1, thread 2. Like 4 quad core processor can have 8 threads, nothing but 8 vCPUs. This is a basic functionality of a compute which every developer should have idea, because when it comes to cloud, we won't talk about a physical compute. Everything is a virtual compute. So virtual compute means virtual machines. The backend is virtual CPU. Mainly Spark, because we will split and process as a partition. This is very important for Spark developers. Remember this. Next one, cluster. So what is exactly cluster? And when you talk about a compute, huge compute, right? So cluster can have a nodes. Each node is 1 VM. In this scenario, cluster is a huge compute. Consider you're having a laptop. That laptop, we will call it as single node cluster. A laptop or a desktop, we will call it a single node cluster. So that single node will have some GB RAM, maybe 4 GB RAM, and some 2 CPUs, maybe 500 GB disk. It's like your single system, we can treat as a single home, or you can say individual house. Single home or individual house. When it comes to apartment can have a number of houses. So each flat we will treat as a node here. Let me show you with some example. So most of the people will have beginners will have some confusion on individual house. Let me show you one image. Let's talk about this. So this is a single node cluster. In individual house, you can treat as a single node cluster, or you can see your laptop or a desktop. 1 BHK or 2 BHK, whatever, depends on capacity. If you talk about apartments, consider if you look at this, one apartment is nothing but one big cluster, one cluster. So one cluster is nothing but one apartment. You can treat as simple way, and this apartment can have a number of flats. Flats is nothing but maybe 2 BHK, 1 BHK, 3 BHK, like this. So that each flat you can treat as a node. Each flat you can treat as a node. A cluster is like apartment. Cluster can have a nodes. So apartment can have a flats. Apartment have a flats. Flats means maybe 2 BHK, 1 BHK, 3 BHK, depends on capacity. Okay. So similarly, when you talk about here, cluster is nothing but a huge compute That huge compute can have an n number of nodes, node 1, node 2, node 3, node 4, node 5, which having some, this everything is a VM, virtual machine. VM, virtual machine. It's a VM. On physical compute, will create a number of VMs. It will use the same configuration, nothing but it's like apartment. We are building on the same physical location. So virtually. So here also, your nodes are VM, virtual machines. But whatever each node is having the capacity, right? That cluster capacity only, cluster capacity, physical server capacity. We can go with the n number of nodes. And when you talk about master and slave architecture, it may be MPP, it may be Spark, it may be Hadoop Map Reduce, Hadoop, MR, it may be Spark. You can choose anything, master and slave architecture. One master node will be there, multiple worker nodes or slave nodes will be there. Whenever you submit any code or job or request, first the request will go and submit on master node, then master node distribute the work. It may be MPP architecture like a Snowflake, Synapse, Redshift, Teradata. So there are many MPP data warehouses are available, or Hadoop MapReduce or Spark. Concept is same. Request will be submitted in one place, that master node or header node or name node. You can call it as any name. And data processed in different nodes. Those we will call it as a slave node, worker node, or process node, worker node, slave node, data node, or process node, where data is going to process. So this is about master and slave architecture. Master and slave architecture. So everything is virtual machine only. Everything is virtual machine only. But most of the people will have a common questions. What is exactly Hadoop MapReduce and why Spark came into the picture? What is exactly Hadoop MapReduce and why Spark came into the picture? So Hadoop MapReduce. So Hadoop MapReduce mainly for processing engine. Big data is having a two concept, separate storage, separate process, or nothing but separate computer. So that storage you can call it as a Hadoop distributed file system or any data lake in cloud. Maybe Azure data lake in Azure, or maybe Amazon S3 or a Google file system or Google cloud storage. So all are distributed storages. And Hadoop MapReduce is a Java program mainly designed to process data and analyze data on top of distributed file system. Then why Spark came into the picture? So Hadoop MapReduce always it's process on disk. So it's read data from HDFS. Then if you are doing any transformations like any operations, every operation it's read from disk, write into disk. It's read from disk, write into disk. It's read from here, write into here. It's read from here, write into here. It's read from here, write into here. Every iterative operations, it is going to read and write into a distributed file system only, but on disk. Distributed file system only, but on disk. Disk is slower than RAM and CPU. Your RAM is, your in-memory is faster than disk and network, right? So when it comes to Spark, it read from HDFS or any distributed file system or any data lake, but processing will happen on in-memory RAM. Your in-memory is faster than disk. How much faster? 10 to 100 times faster than 10 to 100 times faster than disk and network. Your in-memory faster than disk and network. This is one of the primary reasons they introduced. And another reasons now why we are mainly looking at a cloud level Spark means there are plenty of reasons are available. Plenty of benefits are available. So when it comes to key differences, when you compare with the Spark and Hadoop MapReduce, one is a speed because Spark process on in-memory, Hadoop MapReduce process on disk. So your in-memory is faster than disk always. Flexibility. So Spark is mainly general purpose compute, cluster computing is nothing but distributed in-memory parallel processing engine. Distributed in-memory parallel processing engine. So Spark supports multiple, Spark is having a multiple inbuilt libraries for SQL, for streaming, for machine learning, for graphs data processing. And when it comes to processing point of view, it can handle batch data, it can handle streaming data. Spark can handle both real-time data, but MapReduce mainly designed for batch processing. And when it comes to internal tracking, like a lineage point of view, when it comes to metadata, internal metadata, jobs point of view, so DAG, directed acyclic graph, will be there. It will take care of the internal data flow. Okay. And Hadoop MapReduce uses two-stage pipeline. Map and reduce two-stage pipeline. Then easy of use, so Python, other multiple languages like majorly any data engineering project, analytics project, SQL and Python widely using now. So Spark supports R, Python, SQL languages, even developed using Scala, but primarily we are using Python SQL for analytics in cloud. So when it comes to Hadoop MapReduce, developed using Java, and it will support a few languages. Okay, so that's about languages support if you look at this. So Spark supports Python, R, Scala, and SQL. That's a majorly. Okay, when it comes to cloud, R and Python and SQL is widely used in cloud analytics projects, data engineering projects. Okay, data engineering means SQL and Python. So when it comes to, that's about the languages support and resource management. So Databricks or Spark inbuilt, they are having their own standalone resource manager. Databricks, they won't use third-party resource managers like Yarn and Mesos. But MapReduce, they're depending on third-party resource managers. Those also open source, Apache Mesos or Hadoop Yarn. So those are third-party resource managers. Even Spark also supports that, but in Databricks, we won't use that third-party resource managers. And maybe on-premises or any customized environments, you can find that. Spark also supports that. So this is about a major difference between Spark and Hadoop MapReduce. Primarily, if you concentrate on majorly Spark features, these are in-memory distributed parallel processing, RDD, resilient distributed data process. Okay, resilient distributed data sets, mainly distributed data processing point of view. Inbuilt library for machine learning, SQL, and data structured streaming and SQL and machine learning. And DAG manages internal architecture and metadata process, internal process point of view, and support multiple languages, interactive shell. Cluster manager, inbuilt standalone cluster manager is available, and data source connectors. It is providing inbuilt connectors for reading data from normal file system, distributed file system, or any other databases. So ODBC, JDBC kind of databases, which you can read and write data into databases as well. That's the flexibility. Okay, so then let's move on. Majorly when you talk about Spark core architecture. So master and slave architecture. Your Spark driver node or master node will be there, and worker node. So when it comes to cloud, everything is virtual machine. Everything is one machine, virtual machine. One driver node where Spark core will be there, and worker nodes where Java, JVM, Java virtual machine will be there. We'll call it as executor. It's in-memory processing, right? So JVM, Java virtual machine, JVM will be there. That is executor. Whenever you submit any task, it is going to submit on driver node. Your driver node is going to split and process on worker nodes or data nodes. So it can go with n number of data nodes. Even Databricks supports single node cluster, multi-node cluster. Single node cluster means driver and executor will be there in the same node, only one node, that is called local mode. Local mode. Multi-node cluster is nothing but separate driver node, separate worker nodes. Both are possible. Both are possible. So let me tell you, I'll create one cluster in Databricks. If you go to the Databricks compute, you can find a cluster. If there is an option, you can go with a single node cluster. Single node cluster is this one. The same node will have a driver and executor, Java virtual machine, where it will process your data, where it will process your your code, where it will execute your code, and it will process. Our client is a notebook. Our client is notebook. Or you can go with a multi-node cluster, one master node or driver node, n number of data nodes or worker nodes. So that is possible even in Databricks community edition default is single node, or even enterprise edition also you see the single node. If you're looking for multi-node cluster, here also you can go with a multi-node cluster. Consider minimum one worker node, maximum two worker nodes, and the configuration you can choose this. So one driver node, two minimum one worker node with auto scaling option. Even if you're not using, if you want to terminate after minimum 10 minutes, you have to mention this, then create a cluster. Your cluster will be available within a 5 minutes, 3 to 5 minutes. So sometimes it can take 2 minutes, 3 minutes, 4 minutes, 5 minutes. Maximum is 5 minutes, within a 5 minutes. So on premises, if you want to configure big data Spark cluster, if you go back 7-8 years back, like before 2015, right? There was a huge demand for big data administrators. So creating driver node, configuring worker nodes, it's a huge time consuming process. So minimum it will take 8 to 24 hours. Even after that, there is no guarantee your Spark will be available or Hadoop Map Reduce will be available. So when it comes to on-premises, before 2015, if Databricks is not there in a cloud, even Azure is having HD inside clusters, those clusters also will take minimum 1 hour for availability initial days. On-premises, minimum 8 to 24 hours for big data cluster. Before 2014, there was a huge demand for big data cluster. Now there is no requirement for big data administrators. Lot of people lost their jobs. When it comes to cloud, they don't need big data administrators. Okay, they need a DevOps people to manage the infrastructure because it is managed by cloud service provider. So Databricks is helping a lot for creating a big data cluster. Just a single click. Just selected some option and creating. Backend, they are using a Docker images. Backend, they are using a Docker images. The Docker images, every virtual machine, they'll deploy Docker image, pre-configured image with a Ubuntu Linux, and default, they'll already configure the Spark, Python, Scala, all these languages. Just it will go and deploy that image, Docker image. That's why it is available for us between 3 to 5 minutes. Sometimes 2 minutes, sometimes 3 minutes. If you go to the event log, your big data cluster will be available between 2 to 5 minutes, maximum 5 minutes. Okay, so that is possible with cloud infrastructure. Okay, with the help of virtual machine, containerization, or you can say virtual machines. So Docker is a containerized services, which Databricks is using a Docker. Backend operating system is Ubuntu operating system. Okay, so that's about your cluster will be available with what we did when one driver node, two worker nodes. One is minimum, two is maximum. Auto scaling I did. Auto scaling advantages. If you have a demand only one, use only one, pay for this two. Okay. If you have a demand of two, use two, pay for those two. If you have a demand of four, go for four, pay for that. If you have a demand of more 10 worker nodes, go and use the 10 worker nodes, pay for that. That is called pay as you go. If you have a more demand, use and pay. So that's the advantage of cloud services. That's the advantage of cloud services. Then we'll go back. We'll understand Spark architecture. So this is very important. Authentication, authorization. Like consider you have Netflix. So if you are going to log in, so you should have some account. So once you log in, nothing but using a credentials, you log into the account. One session will be created. User session will be created. So user session will be created. That is called authentication. So once you log into the applications, right? If you want to access, like you want to watch some movies, you want to watch some series. So you need a subscription. Without subscription, you cannot watch. That is called authorization. So privileges to access those services. Privileges to access those services. That is called authorization. Authentication is just a user session will be created. You need some account. Once you log into that, session will be created. User session will be created. Then you can use any subscription and go and watch that. That is called authorization. Privileges. Like if you want to watch kids movies, if you want to watch series, movies, anything, documentaries, anything you can watch. That is called authentication authorization. So similarly, when you talk about Spark, Spark also is having similar kind of concept. Like every database will have a, whenever you log in using a database SQL user and password, then it will create one session, user session. It will create a backend user session. So that is SQL session will be created. Then whenever you submit a code on a particular server, the backend context will be there. It will go and create separate context for you. Similarly, whenever you use a notebook and you need to communicate to the Spark, right? So that is Spark session. Session will be available, a variable called Spark. A variable called Spark. And different kinds of contexts are available. Spark core is nothing but RDD. If you want to communicate Spark core, primarily RDD. Then they introduced the SQL module, separate SQL module. So initially they introduced the Spark core, right? For that they have a separate context called SQL context. They have a separate context called Spark context. Initially Spark session, Spark context. Then they introduced the SQL separate module for data frame, data process, and SQL they introduced. For that, they introduced separate context called SQL context. Similarly, structured streaming, they have a streaming context. So multiple contexts are available. Spark session is for authentication and context are for authorization. Context are for authorization. But what they did, again, they in between they introduced the Hive context as well, mainly running a Hive SQL in Spark. So Spark context, SQL context, Hive context. So if you have a multiple context, right, obviously developers will have a confusion. So what they did, whatever your SQL context is going to do, privileges they granted to Spark session. Boss, you don't need to worry about a SQL context. You don't need to worry about a Spark context. You don't need to worry about a Hive context. Even if you have a multiple context, go and use a Spark session. So they have granted SQL context, Spark context, all this Hive context privileges to Spark session. Now Spark session can manage as for authentication plus authorization. Now Spark 2.0, 2.0 version onwards, Spark session is having a privileges as you can go and use directly create a data frame, directly data set. For data frame, data set, they introduced one module called SQL. So for that, they used a context called SQL context. So you no need to use SQL context. You no need to use a Spark context. Go and use a Spark session. That privileges are already granted to Spark session. So Spark session is like both now, authentication plus authorization. Authentication, authorization. Let me show you that. Let me show you that. So now cluster is available. You can verify how much time it has taken. So driver is healthy. 35, 48 seconds. 39, you say this, 38, 52 seconds. So 3 minutes, then 4 seconds. 3 minutes, 4 seconds. So 3 minutes, 4 seconds. So 2 to 5 minutes in between. Sometimes 4 minutes, sometimes 3 minutes, sometimes 2.5 minutes. Very rare scenarios I observed less than 1 minute, 1 minute or less than 1. Very rare scenarios within 1 minute your Spark cluster is available. Now if you verify, 2 nodes are available, one driver node, one worker node, another worker node which you can go with based on demand basis. That you can go and verify in metrics. There is a Ganglia UI as available. You can go and verify clusters, how many up clusters. Total 8 CPUs are available. All are virtual CPUs. 2 nodes, one driver node, one worker node, those IP addresses. Okay. And now, if you go to create any notebook, Spark core. So as I told you, right, Spark session is available a variable called Spark. Spark context is available a variable called SC. Okay. And Spark SQL context also is available as SQL context. Still it is available, but you don't need to worry about multiple context. Spark session is having a privileges of authentication plus authorization. Nothing but Spark session not only for authentication, like a communicating to the Spark first, then authorization. So working mainly on submitting a code and converting in a backend process. When it comes to SQL, entire internal process like SQL context will take care. So that same Spark session also can take care. Similarly, SQL context, Spark context, or Hive context. So the Spark session is having all privileges plus authentication, both. So whenever you assign this notebook, right? So backend, you can find this. Whenever you assign a cluster here, you see this cluster is assigned, and the backend Spark session available in a variable called Spark. Spark context is available a variable called SE, and SQL context is available a variable called SQL context. Let's create RDD. What is RDD and how to create RDD and how many ways we can create RDD? So RDD means resilient distributed data set. Like database will create a tables. So here we'll create RDD. It is a programming language. So I'm going to create RDD. Any name you can take. Ravi RDD. So one is a Spark context. You can use parallelize method. And input is array. So Python list. So this is one method which you can go and create RDD. And you can verify type of the object using a Python function. You can verify type of the object. It is Pyspark RDD. Even you can use Spark session dot Spark context. So even you can use Spark session dot Spark context. So that there's another way which you can create RDD. It is RDD. So on top of RDD, you can apply two operations: transformations, actions. If you are going to display the data, if you are going to print the data or display the data or save the data, that we will call it as actions. If you are going to change anything like changing metadata, changing data, like nothing but in database, we will call it as a data definition language, data manipulation language. So changing structure, changing data, data and metadata, data manipulation, data definition. So that you can treat as a transformations here. When it comes to data retrieval language, DRL, retrieving existing data, that is printing data or displaying data or saving data. We'll call it as actions. We'll call it as actions. Transformations means changing. So whenever you trigger action, then job will be triggered. If whenever you apply transformation, transformations are lazy. Transformations are lazy. Here you look at this. You can go with the n number of transformation. Every transformation, it will return new RDD because your RDD is immutable. Your RDD means resilient distributed data set. Resilient means self-recovery. If any issues are there internally, it can fix internally. That is called resilient. Lazy execution. Your transformations are lazy evaluated or executed. Means whenever you apply transformation, your RDD is immutable. Immutable means uneditable. So whenever you apply transformation, it will return another RDD. So RDD1, RDD2, RDD3, RDD4. But all are lazy. Only metadata lineage will be created and the DAG will be managed, that directed acyclic graph. Once you run an action, then only it will run this action, all this backend metadata, then it will return a value. Until then, those are lazy executed. Those are lazy executed. It's like train. The best example is train. If you take any train as an example here, your train engine is action. If there is an action, then only this passengers will move from source to destination. Until then, they are lazy. They cannot move themselves from source to destination. Consider you're traveling from Bangalore to Hyderabad. If train engine is not there, those are lazy. Lazy means they are not evaluated. I can say they are not moved from source to destination. They'll move source to destination only with the help of engine. Engine is the trigger point, nothing but action. Engine is the trigger point. So similarly, when it comes to here Spark, your transformations are like where passenger will be there, passenger bogies. So those will send to the destination only there is an action. So if you do the action, then only they will send to the destination. Nothing but those are lazy executed, lazy evaluated. Whenever you use action, then only it will display the data. So let's talk about a few transformations. We'll understand that. Okay. So I created RDD. Let's go with some more values. You can create RDD using a range function as well. I'll go with a range of 15. So if you want to display the data, so collect is one of the action. It will display the data. Whenever you run a action, this will be executed and the job, backend job will be executed. Job divides into stages, stages divides into task. By default, whenever you go with the parallelize method, it will create 8 parallel processes, nothing but 8 partitions. If you're looking for partition wise data, use a glom function. Okay, by default, when it comes to parallelize method, default 8, but when it comes to here, default it is going with a 4. Default it is going with a 4. And the second argument which you can specify, consider I want 6 parallel processes. Now if you go and verify, it will create a 6. 1, 2, 3, 4, 5, 6. Okay, now even I can go with the 8 parallel processes. 8 parallel processes. 1, 2, 3, 4, 5, 6, 7, 8. So what will happen in backend? I'll tell you that. Your job divides into stages. Stages divides into tasks. 8 tasks will be submitted on worker node. Job is nothing but a piece of code, maybe reading data or writing data. So we are reading data and displaying here. This is one job. Job divides into stages. So that depends on operation. It can go with one stage or more than one stage. More than one stage. So more than one stage depends on operations. That we will call it as a narrow transformation, wide transformation. I'll give you the example as well. What is a narrow transformation? What is wide transformation? I'll give you the example. Job divides into stages, stages divides into task. Always task depends on number of partitions. If 8 partitions are there, it will submit 8 tasks. If you have a 4 partitions, it will submit as 4 tasks. You can see this 4 tasks. You can go to the view, you can verify this. Job divided into stages. The stage description, you can find the link. Click on that link. It will be routed to task information. How many tasks it is submitted, where it is submitted, which node it is submitted. Always Python start indexes with a 0, task 0, task 1, task 2, task 3. 4 tasks. Which node it is submitted? This is the node. This is the node. Worker node. Driver node is different, worker node is different. Okay, if you go to the environment, you can find information about your complete information like tags and other information you can find here. Okay, now, so here it is about a driver IP, container private IP, instance IP, multiple like cloud level information you can find this. Now, if you go to the executors, so here one driver node, one worker node is available. You see driver node IP, worker node IP. So driver node, where your job is submitted in driver node, where task will be submitted here. Task will be submitted on worker node. If you go to the jobs to stages, stages to task. Your task will be submitted on, you see this. This is a worker node. Let me help you to understand more detail level. Okay. So whenever you submit a code through the developer through notebook, right? Code will be submitted in a master node or driver node that is called job. In driver, job divides into stages. The stages may be one stage means narrow transformation, more than one stage means wide transformation. I'll tell you that. Stages divides into task. stages divides into task. The task always depends on partitions. One task, one partition means one task. If you have one partition, one task. If you have 10 partitions, it will submit as 10 tasks. So those tasks will be submitted on worker node to process your data. So your data will divide into multiple partitions. That data is going to process on worker node. Mean one task you need one virtual CPU, vCPU. This is. If you are submitting a 4 task, right? Nothing but 4 partitions will be submitted as 4 tasks from driver. Driver means job to stages, stages to task. Task depends on number of partitions. 4 partitions means 4 tasks. Your executor will have a available slots. Slot is nothing but available vCPU, virtual CPU, nothing but thread. So here 2 available vCPUs, 2 slots are available, 2 slots are available, 2 slots are available, 2 slots are available. So in this, you can go and submit your task. So that slot is occupied with a task. This slot is occupied with a task. This slot is occupied with a task. So this slot is not occupied. It is available for task. This slot is not occupied. Available for task. Available for task. Slot is occupied with the task. Slot is occupied with the task. A simple way to understand. Consider you are a team lead. You are having, okay, you are having a 10 tasks, okay, or maybe 5 tasks. You are a team lead. You are a team lead. You are having a 5 tasks to complete. So you are having a 8 developers. 8 developers. Just I'm giving a simple example. So 5 tasks you assign for 5 developers. So developer 1 you assign, developer 2 assign, developer 3 assign, developer 4 you assign, developer 5 assign. So 5 tasks you assign to 5 developers. Remaining 3 developers are free. Developer 6, 7, 8 developers are free. Free means they are available for work. Slot is availability. Slot is available for a task execution. So wherever you see the task, that task is occupied. So the slot is occupied with a task. So this is about internal terminology. This is about internal terminology on driver node, worker node. Driver node, your job will be submitted. Job divides into stages. Stages divides into task. Your task is going to submit on worker node. Every worker node will have a vCPUs, nothing but available slots. vCPUs means available slots. Let me explain with here. We are having 2 nodes, right? We are having 2 nodes. One driver node, one worker node. So we went for 2 maximum, but available 1 worker node available, 1 driver available. 4 cores. 4 cores is nothing but 4 vCPUs. You can run 4 tasks. You can run 4 tasks. Okay, now let's go back, understand more into transformation. So now this is displaying data partition wise. Use a glom function, then collect will display the data. So collect is an action, and similarly you can go with the count. It will give you number of partitions are available. 4 partitions are available. Glom, then count. Okay, if you remove glom, then it will give you number of items. Number of items means 15 items, 0 to 14, 15 items are available. This is number of items, 15. In that minimum value, 0, maximum value, these are our actions. Whenever you use the actions, right, it will run a job, it will display the output. Printing data is nothing but action. Okay, stats, it will give you mean, standard deviation, count, minimum, maximum. Average, standard deviation, max, minimum, count. Or top, you can go with the top 4, 14, 13, 12, 11. Or you can go with the take 4, so 0 to 3. Or only first. So these are our actions to display the data. What you can do? You can go with take n number of items. You can go with the top n number of items. You can go with, if it is a numeric, minimum, numeric, maximum, numeric average means mean. You can go with the standard deviation. Okay, then you can go with the total count number of items. So this count will work for normal any RDD. Even you can go with the stats. You can go with the collect. It will display total. Even you can go with glom partition wise, then collect. Okay, partition wise displaying, you can use a glom. Even there is a function called get num partitions. It will give you a number of partitions. It will give you number of partitions. So in a Spark context, default parallelism. So Spark context is having a function called that's a parameter. Default parallelism is 4. That's why whenever you go with the parallelize method, it is creating a 4. Okay, when you go with the community edition single node cluster, default is 8. But here default is 4, which we can change this. Whenever you are creating RDD, you can go with the second argument here. That is a default parallelism. Even when you are going for creating RDD with some text file, it will go with the minimum two partitions. Okay, so this is about creating RDD. Let's talk about narrow and wide transformations. Narrow and wide transformations. I'll go with 8 or 4 partitions. Let's display data. Let's display this data with a glom. So glom means partition wise. You see this job to stages, 4 tasks, because 4 partitions are there: partition 1, partition 2, partition 3, partition 4. If you want to decrease number of partitions, we can use the 2 options: collies, repartition. We have 2 options. I'll give you both options. Print. So one is collies. Collies I'll go with 2. Same thing, I'll go with the repartition as well. I'm trying to decrease number of partitions 4 to 2. So collies, first one is collies, second one is repartition. So partition 1, partition 2, it is worked well. Here also partition 1, partition 2, 2 partitions it is created. But which one is narrow, which one is a wide transformation means collies is narrow transformation, repartition is wide transformation. Let me explain this. The collies is went for single stage, only one stage. So no shuffling. No shuffling means no shuffle right, shuffle read. But when it comes to repartition also 2 partitions only. But if you look at the data, it is went for shuffle right, shuffle read. 2 stages it's went. 2 stages. So if you go with a single stage, no shuffle right, no shuffle read, that is called narrow transformation. If you have a shuffle right, shuffle read, that is wide transformation. I'll show you that. Okay. Now, then what will happen when you go with the collies? Nearby partitions, it will merge. These 2 partitions, it's merged. If you look at the output also, you see clearly. These 2 partitions, it merged. These 2 partitions, it is merged. Nearby partitions, it will merge. Nearby partitions, it will merge. This 2, this 2. When you go with the repartition, it will recreate new partitions. So first it will take 4, it will write in memory, shuffle write. Then it will exchange the data, it will create a new partitions, 2 new partitions. So when you go with the view, if you look at the view, you can see this. You can find a stage 1, stage 2. Shuffle write, shuffle read, this one. First 4 it will write in memory. Then it will read as a 2. Shuffle write, shuffle read. 2 stages, stage 1, stage 2. Clearly you can see this. Stage 1, 17, number 17, 18. Here also you can see this, 17, 18. If you go with the collies only single stage, 16 stage, and 2 partitions, and no shuffle write, shuffle read. Let me explain with a more clarity This one. So whenever you go with the coalesce 2, nearby partitions, it will merge. These two partitions, it will merge. So RDDX, then RDDY. Because RDD is immutable, you can add update here. It will take input as RDDX, consider. Another RDD it will return. That RDD will have a partition 1, partition 2. But nearby partitions data, it will merge. You see this. Coalesce, it won't do any shuffling. Coalesce, it won't do any shuffling. Then when you go with the Y transformation, shuffling. So shuffling means first RDDX, it will take data 4 partitions. It will write in memory as it is. Then it will shuffle the data. And even while writing also shuffling is required. Shuffle can be done. Shuffle can be done from this can be go here, this can be go here. But I'm not given that full diagram. But shuffle write. 4 partitions it will write in memory, then shuffle read, then it will shuffle and it will give you 2 partitions. So RDDY, you will get a partition 1, partition 2. So this additional 2 steps are there: shuffle write, shuffle read. Your input RDD, output RDD. In between, you can find 2 stages. Stage 1, shuffle write, stage 2, shuffle read. When you go with this one, directly it will read data from source and then it will give you an output. Single stage operation, here 2-stage operation, here 2-stage operation. Shuffle write, shuffle read. So that steps you can find here. If you go to the view, you can find this. Any Y transformation, if you verify, you can find this. If you find any shuffle write, shuffle read, that is Y transformation. And it will go with the 2-stage operations. So in this scenario, repartition is Y transformation, coalesce is single stage narrow transformation. And if you are looking for reducing number of partitions, instead of repartition, use coalesce, because coalesce won't work for increasing. If you have a requirement of increasing, then go for repartition. I'll try to increase. RDD works for both increasing and decreasing, but data frame won't work. But here we are using RDD. Default is 4. I'll try to increase 6. So repartition is not increased to 6. Partition 1, 2, 3, 4 only is there. But coalesce is not increased. Only 4 is there. It is not increased to 6. But repartition is increased. 1, 2, 3, 4, 5, 6. If you look at the job, this is narrow, this is wide. Shuffle right, shuffle read is there. 4 input, output 6 partitions. But coalesce in RDD level, it can increase or decrease. The second argument is true. Shuffling is true. Now this is increased. Now both are increased. Both are, you see this, Y transformations now. In this scenario, your coalesce, if you go with the second argument true, shuffling is true, then coalesce same as like a repartition. It will go with the 2 stages. Shuffle right, shuffle read will be there. Shuffle right, shuffle read will be there. Both are same in this scenario. But coalesce won't work for increasing at data frame level, because RDD only for understanding a Spark architecture. RDD only understanding Spark architecture, and it is not available for increasing in data frame level. So past few years, like from 2016-17, we are using only data frame. We never use RDD for data processing, mainly any data warehousing project in Databricks or any semi-structured data, unstructured data, structured data. Data frame only will be using that. So data frame is better than RDD. You'll get a SQL optimizer and a lot of transformations and functions you can use. So that's why data frame we will use. The RDD is just to understand Spark core. So coalesce is available at RDD level, data frame level, but you cannot increase at data frame level. You can increase and decrease with a true option at the RDD level. But if you use a true option, then it will go with a shuffle right, shuffle read. When you go with the decreasing, you see this. So decreasing shuffle is true. Decreasing shuffle is true. So now you see this. Whenever you go with the coalesce second argument, Then shuffle right, shuffle is there. Now that is not a narrow, that will become wide transformation. Shuffle right, shuffle read will be there. Shuffle right, shuffle read will be there. So this is about what is narrow transformation, what is wide transformation. Then you can go and understand Spark core. This is about Spark core, understanding Spark core. I have a given one end-to-end example that is called word count program. Word count program. So I have done one video, word count program. Go through that video. I have given all the transformations and actions with on top of RDD. So this video will give you more about Spark architecture, how to create RDD, narrow transformation, wide transformation. That video will get more clarity on different kinds of transformations and end-to-end understanding. So go through these two videos, you will get clear picture on what is exactly Spark core, what is exactly RDD. But Spark core RDD primarily we are using or understanding just Spark architecture. We won't use in a real time because we are going to use a data frame in a real time projects. So because SQL module is there, data frame will give you more flexibility for data warehousing projects to process semi-structured, structured data, even unstructured data. So the data frame will give you flexibility for structured, semi-structured, unstructured data, plus multiple functions. Mainly data warehousing projects, more requirement will be functions. So that it will help you a lot. SQL optimizer will be there. You can fine tune and you can improve the query performance as well. So that is about Spark core. If you're not yet subscribed, please subscribe my channel. See you in another video. Have a good day and all the best. Thank you all.